Hey guys, my name is Frank, and this is the Python Programming Video Log, Part 7 of how to write a tile-based platforming game in pure HTML5 and JavaScript. In today's video, I'm going to show you how I added animated game objects to the application, so stick around to see how it's done. In this video, I'm going to show you how I define the carrot and grass objects in the level data file, their respective classes, and the basic collision detection used to collide with the carrot objects. If you have any questions about the code, please leave them in the comments below, and be sure to leave a like if you learned something new. The first thing I'm going to talk about is what this example program is all about and where the carrot and grass objects are defined, because since the last installment of this series, I've since added carrot objects and grass objects. You can see that I'm running into the carrot objects, and when I collide with their hitbox, I collect a carrot. I have a carrot counter at the top left of the screen, and then down here I have some grass objects, and all the grass objects are just objects with an X and Y position, and they have an animator inside of them. They extend the animator class, and it just updates the image on every frame of the grass to give the impression that the grass is actually swaying back and forth. So just some basic objects that I've added. And if I come over here and take a look at the zone file, you can see that this is my level data file, and I have an array for carrots, and I have an array for grass, and basically they're just little arrays inside of here that define an X tile position and a Y tile position. So if I come over here to my map and I refresh, this carrot is going to be at position 1, 2. So the X tile is going to start at 0 and go to 1, because this right here is 1, 2. So X tile of 1, Y tile of 2. So if I count from 0, I get 0, 1 on my X tile axis, and for the Y tile axis I have 0, 1, 2. So I know that from this map I want a carrot at position 1, 2, and that's that carrot. Same thing for the grass. My first grass tile is at X position 2, Y position 7, and that's going to be this grass object right here. So pretty simple. So when I load my level up, I'm going to actually have to loop through these arrays here, get the X and Y tile positions from them, and then create an object from that X and Y tile position. And if I am looping through the carrots array, I'll create a carrots object. If I'm looping through the grass array, I'll create a grass object. So let's go in and check out the setup function of the game.world object. The setup function just runs, if I come over here and refresh my screen, the setup function runs right after the level data is loaded. So right after I load this level data and I get access to it with json.parse, I then call the setup function. I pass in the JSON object that I just parsed after I loaded that level data from JSON, and I go ahead and I set up all of the game objects and the graphics and collision map and everything for this level. And then I'm going to go ahead and I'm going to loop through the zone's carrots array and the zone's grass array, and basically those are literally just going to be these two arrays right here. So I'm going to loop through them, and I'm going to create a new carrot and a new grass object for every instance of one of those little X and Y tile arrays that I come across inside of the zone file. So what that looks like is I'm just going to use a for loop. I'm going to go ahead and I'm going to loop through all the carrot objects inside of my zone's carrots array, which is just the little tiny X and Y tile arrays. I'm going to create a carrot object, or not an object, but a variable to store that X and Y position from the zone.carrots array. And then I'm going to store a new game.carrot inside of my game's actual carrots array that I'm going to use on every frame of animation inside of my game cycles or my game loop. So what I'm going to do is I'm going to feed it an X position in pixels, not in tile space. So I'm going to take the X tile position of the carrot, which is located at position 0 inside of that array that we loaded from the level data, and I'm going to multiply it by the tile set.tile height, which is 16 pixels, plus 5 is just going to give me an offset. So if I were to come out here and make this plus 0 and save, I come over here, what's going to happen is I'm not going to have an offset of 5 pixels anymore, so you can see they're kind of offset to the left by 5. If I come back in here and I undo that with the Z, Control Z, save, come back over here and refresh, now all my carrots are in the right position, pretty much. I do the same thing with the grass. basically I just loop through all the grass in the level data file, and I create a new instance, a new grass object, and I just position it based on the X and Y tile values stored in my level data. So that's it. Next I'm going to take a look at the actual classes that we use to make the grass and carrot objects. Now we're going to take a look at the grass and the carrot classes respectively. So first I'm going to start out with the grass class, and all it is really simply an animator object. It inherits from animator. This way I can animate the frames, and it also has an X and Y position. If you look at a grass object, which is just this right down here, obviously all it does is sit in a location, so that's going to be my X and Y position, and it is animated, so it's going to have to inherit from the animator. Now the animator class is the same class that I use to animate the rabbit. It can be reused for all different kinds of game objects to give them an animation. So really simply, the grass class just has an animation and a position, and the carrot class kind of does too, but it also has a lot more. So let's go up and take a look at the carrot class and see what makes it move and how we collide with it with the player object. So here's the carrot class, and it inherits from the object class, the game.object class, as well as the animator class. So the animator class just gives it the animation. The object class is what's going to give it its X and Y position, as well as its width and its height. And in addition to those things, it also gets the collide object function, which is going to be responsible for allowing us to collide with a carrot and actually collect it. So that's important to note. Then some cool features about the carrot. We have the base X, Y, and position X, Y values. So base X and base Y are just referring to the center position that the carrot is rotating around, or making that figure 8 around. So that's going to be the base X and base Y position. The carrot does still have an X and Y position. That's going to be where it's actually drawn to. The base X and base Y are going to be just the point that it rotates around. Position X and position Y are going to be vectors that the carrot is placed by the amount of the vector on whichever axis away from the base X. So to explain that a little more clearly, if base X is in the center, position X and position Y are going to be distances away from the base on their respective axes, and that's what's going to determine how far from the base the carrot is. And we're going to, I'll show you how I'm using position X and position Y in a second. I'm just going to move down here, but I set a random value up here, and that basically just makes all the carrots kind of have a different path, because otherwise, if I just set this up to be, let's see, 0, all the carrots would have the same rotation pattern. They'd all be synchronized, basically. So if you look now, you can see very clearly that they're all synchronized, and that's kind of a bad look. So just go back to how it was before. Save, and now you can see that they all kind of move independently, and it's a lot less jarring to look at, because before it was almost like there was a big, just solid image of carrots with the transparent background just moving back and forth on the screen. That's not what we want to go for. We want to have independent movement. We want to have things looking like everything is random. So also, speaking about that, up here, the frame index. If you notice, all the carrots on screen are not sharing the same animation sequence. Well, they're sharing the same frames, obviously, but if you look at 2, you can see that they're animating at different rates. I just have to find 2 that are going at offset values here. These 2, this one and this one, they display the opposite frame from one another. So when this one is on frame 0, this one's on frame 1. When this one's on frame 1, this one's on frame 0. And that keeps things looking fresh. So if I come up here and change this to just be 0, it's going to reduce the randomization, and we're just going to have everything animating the same exact way, almost like it's updating from the same exact animation object. So that's not what we want either. We want things to randomly update their animation, not randomly, but look like they have their own unique animation, even though they're displaying the same frame. So to do that, all I'm doing is I'm starting off the animation at a randomized frame index. Alright, so now let's take a look at what actually makes these things rotate around the base X and base Y position. Inside of the game.caret.prototype, which is going to be the prototype for our caret class, I have a function called update position, and that's the only function for this class. And this is going to be called on every frame of animation. We're going to talk about this in the next part, but all it does is it updates the position X and position Y value and sets the actual X and actual Y value of the caret object, which we're going to use to draw it to the screen. So, excuse me. Position X and position Y, what it does is it's just a distance from the base. So you can think of it as a vector distance from the base. So, oh, actually, well, that is true, but when I'm updating these, it kind of controls the speed of the animation. So if I were to make this 5 and this 9 and save, we're going to see the carets move a lot more quickly. So when I press refresh up here, now they're really moving. Like, those guys are jumping around quite a bit there. So that controls the speed at which things move, because on every frame of the animation I'm adding 0.5 or 0.9 to these, and that's going to make the thing move a lot more quickly, obviously. So let's get back to how things were. Save, come down here and look at how we actually use these. So math.cosine and math.sine are what's going to give us that circular motion, and we just plug in position X and position Y into cosine and sine. And over here we have a multiplier of 2. That's going to control the distance that the caret sways on the x-axis. So if I come over here and refresh to get things back to normal, you can see that it sways a little bit further from side to side than it does from top to bottom there. So the reason for that is because of this 2. If I were to make this a 10 and save that, the carets are going to sway a lot more from side to side than they do right now. So now you can see they're really swaying from side to side, but that looks kind of ridiculous, so we don't want that. But basically what's happening here is we're just we're incrementing up position X and position Y. Math.cosine and math.sine give us a nice rounded or circular kind of effect there, and then the multiplier is just going to be how big is that distance vector from the base position. I guess it's actually a scalar because it's only one single value, but together they make a vector. So let's just put that back to 2. So on every frame, I'm going to call update position, and this code is going to run, and it's going to make the caret move back and forth. Now, if I refresh, everything's back to normal. So next, I'm going to talk about how we actually do the collision between the caret and the player. To do the collision detection between the player object and the caret object, we need a function that basically just does collision detection between 2 square hitboxes. So where that function is inside of game.object. So I'm going to scroll up to game.object, and we're going to take a look at the function that we use to do that hit detection. So here's the game.object.prototype. That's just the prototype for our game.object class, and we have collide object. And what collide object does is it just tests for square collision detection between 2 rectangular objects. So this object is going to collide with the parameter object that I hand in. So basically I'll be able to hand in 2 objects and determine whether or not their hitboxes are overlapping. So just wanted to show you this function, and now you'll kind of know where the collision detection function is coming from. Where I'm actually utilizing all this is going to be inside of game.world's update function. So I'm going to come all the way down to the bottom, all the way down past the player object, past the tile set object, to the world object, inside of the, not the setup function, but the update function. So here we are inside of the update function, and here we are going to call all of this code on every frame of our game's animation. And we start up, we update the player's position, we collide the player with the game world to get the tile collision going, and then we're going to start colliding with carets. So we have a carets array that's going to hold all of our caret objects that we created inside of game.setup, or game.world.setup rather. We're going to loop through all of those caret objects, so just these guys here, and we are going to update the caret's position. We're going to animate the caret, and then we're going to say, is the caret colliding with the player, with the collide object function? If that function returns true, we're going to splice that specific caret out of the carets array, and we're going to just remove it completely. And we're going to add 1 to caret count. And it's as simple as that. We're just going to test for collision between the player and the caret. If collision occurs, we're going to just remove the caret. The caret object is totally gone. It will be garbage collected later on, assuming that I removed all references to it. And I think I have. So then what's going to happen is I'm going to increase caret count by 1. And caret count is what we're using to update this p element's inner HTML right here. So where does that happen? That happens inside of the main.js file. If I come down to the render function, I have a p element. It's referenced with the p variable, and I just set its inner HTML to equal carets plus game.world.caret count on every frame. And that's it. Now you should have a basic understanding of how to add interactive objects to your game. Most of the code used to add these objects was already written to handle the player, so at this point in development it's really easy to add new objects. If you have any questions, just leave them in the comment section and I'll see you guys in the next video.